Hello everyone, welcome back to Learn Math with J, where we make mathematics simple, practical, and easy to understand. I am Jaffo, and in this lesson, we'll be learning about some simple theory mode, circle theorem proofs, and we have a simple question that we are going to prove. It goes like, prove that the angle at the center is twice the angle at the circumference, subtended by the same chord. So what we are going to do is that we are going to prove that the angle. So let's draw circle to represent that. Have a circle. Now we are saying that the angle at the circumference, so is actually what, or the angle at the center is actually twice the angle at the circumference, subtended by the same chord. Let's do something here. Now this is our center, right? Let's denote this center as O, then here as A, B, and C, right? So we want to show that the angle AOC is equal to 2 times angle ABC. That is what we are going to do today. And from the question that we had, yes, that's what we're going to do. So we want to actually show that this angle here is twice this angle. Now let's do something here. Let's try and divide this angle into 2 and name this angle X and name this angle Y. Now let's see something here. Now it means that our angle, this angle here, so let's do something here. Let's angle ABC be equal to B. So it means that our B will be equal to what? X plus Y. Now let's denote angle AOB as P and angle BOC as Q. Now so it means that we can write here Q, here P. Now let's denote the angle A, which is the angle at the center, OC, as what? A. So you can write this one as A. Right. Now this is radius, this is another radius. So the distance from here to this point is the same as the distance from here to this point. So this forms what? An isosceles what? Triangle. So it means that if this base angle is X, this also what? X. The same thing applies to this place. We have Y here. Right. Now let's do something. Now from triangle AOB, we know that the sum of the interior angles of a triangle is 180 degrees, right? So it means that we can boldly write that X plus P is equal to 180 degrees. Then also, this is going to give us 2x plus P equal to 180 degrees. Now let's make P the subject here. So P will be equal to what? 180 degrees minus what? Minus 2x. Let's name this as our equation 1. Right. So let's do something here. Now let's consider triangle BOC. Considering that part 2, it means that we have Q plus y equal to 180 degrees. Then we have 2y plus q equal to what? 180 degrees. And this is actually going to give us q being equal to what? Being equal to 180 degrees minus 2y. Let's name this as our equation 2. Now let's look at the diagram. Those angles here, P plus Q plus A, all sum up to what? 360 degrees, because these are angles at what? A point. Now, we know A here is what? The angle AOC. P, we have it here. Q, we have it here. Let's do the substitution and see. So what happened next? Now we have P being 180 minus 2x, then plus 180 minus 2y, plus A equal to what? 360 degrees. Then from here we have, when we add this, we have 360 degrees, then minus 2x minus 2y plus A equal to what? 360 degrees. Now this is actually going to give us what? This will go out. Now we have A being equal to 2x plus 2y. Right, so A will be equal to 2 out x plus y. Now let's look at something here. We said that this angle that we wanted to show, that angle AOC is equal to 2 times the angle ABC. Now our angle AOC, we use what? A to represent it. So it means that at this point we can write angle AOC equal to 2 times, what is x plus y? From our diagram, x plus y is the angle, angle what? ABC. So that will be equal to 2 times angle ABC. Hence proved. Right. So this is what we wanted to actually arrive at. So this is it. So that is the proof for that. It means that the angle at the center is twice the angle at the circumference, subtended by the same chord. And the proof tells us this one all. Thank you for watching.